I'm Richard Hollingham. Welcome to the Planet Earth podcast. This week I'm in central London to discover how to make centuries-old buildings green and energy efficient without tearing them down. And what lurks behind the aircraft hangar at a British research station in Antarctica.
Hello. Weddell seals are one of the more friendly seals that we've got on base. They kind of look a bit cat-like.
It's only when you pull a hamstring, break a leg or do your back in that you truly appreciate the ability to walk. Unlike most other mammals on this planet, we do it with 2 legs, not 4, and without a long tail to balance our bodies. The only animal that walks like us is the orangutan, which is why studying both humans and orangutans can help uncover how and why our common ancestor started walking upright on 2 feet. Sue Nelson went to meet a scientist who specialises in how humans and other animals move, to find out how and why it's done.
Birmingham may have been called a concrete jungle in the past, but few people are probably aware that inside the university, part of a real jungle has been recreated. It's inside the Posture and Balance Lab, which is where I am now with Dr. Susanna Thorpe and 2 of the members of her team. Susanna, posture and balance, that's, I assume, why what looks like a beam quite low off the ground is in the middle of this lab, although it's cylindrical and it's surrounded by an apparatus, a sort of steel framework of pipes and tubes with cameras above it and a large screen at the end.
What we've tried to create here is the tropical forest, but on a much smaller scale. We're really interested in human evolution, and one of the most important things is how human ancestors started to walk on 2 legs. And our idea is that this began in the trees. So what we've created here is the kind of environment that our early ancestors would have experienced when they were walking on 2 legs and trying to balance on the edges of trees as they're trying to reach for fruit or cross gaps in the canopy.
You say our sort of common ancestors. We haven't got any of those present. So what do you use instead?
So we're using 2 models. We're using humans to try and understand what our ancestors did, but we're also using orangutans. And this is on the basis that we think the origins of bipedalism lie in our ancestors moving around in the canopy of tropical forest. And orangutans are the only one of the great apes, which are our closest living relatives, to still live in that habitat. So they're a perfect model to understand the problems that our ancestors would have faced.
I mentioned that we have 2 members of your team here. One of them is Emma Tequin, who's a doctoral researcher. What role is Emma going to play here? Not that of an orangutan, or is she?
Emma's going to be our guinea pig today. And she's going to walk on the beam, and hopefully she's going to be able to balance on it without falling off.
Emma's also with Dr. Sam Coward. Sam, you designed this equipment here. What are you going to do to Emma in order to examine how she actually walks across this recreated forest branch?
Well, we have a number of cameras in this room which track reflective markers that can be placed on the subject.
How many of these reflective markers do you have to put on Emma's body?
Well, to get enough information to fully recreate her full body movements, we have to put somewhere in the region of 70 markers on the subject. This technology is commonly used in filmmaking, so it's a sort of technology that was used in the making of Gollum.
In Lord of the Rings?
That's correct.
OK, well, let's get those on Emma. Emma is now fully kitted up with more than 70 of these markers. Could you explain, Susanna, what Emma is going to be doing for us here?
She's going to climb onto the beam. You can see that the beam, we have one fixed end and one free end. And obviously it's much harder moving on the free end because it's more flexible, so it's going to bend more under her mass, under her weight.
Which is how a branch in a tree would be.
Yeah, which is how branches behave. And she's going to walk slowly along towards the end of the beam. And if she feels like she might fall off, she's going to use the thinner hand beam to help balance herself.
OK, let's see. Emma, go on. She's got one hand on. She's moving. This beam is only about 3 metres or so long.
Oh, well, I'm starting at the unfixed end, and this is the most flexible end, so the most unstable. So it's getting a little bit easier as I'm walking towards the fixed end, but I'm still having to use the hand beam balance. And there we go, safely on to dry land.
How does it feel compared to how you normally walk?
A lot more unstable. You're kind of wanting to grip with your feet more, which I suppose is similar to what an orangutan would do in the canopy. Yeah, it takes a bit of practice. And this is on the thickest beam, so I dread to think how I'll fare on the narrower ones.
We're trying to get information on all aspects of this movement, both from the perspective of the person moving on the branch and from the perspective of the branch itself. So the beam is instrumented, which means that we can record the forces that the person is exerting on them as they walk. On Emma, we have all these reflective markers, and the cameras are picking those up so that we have very detailed 3D movement of her body and all of the separate limbs, particularly the ones that are holding on to the small branch for balance. Coupled with that, we have an EMG system attached to her muscles as well, which are these sticky plasters that record muscle activity, and they tell us when muscles are active and how active they are. And finally, we also have an ultrasound attached to her muscles, and these tell us how much the tendon is moving and how much the muscle fibres are moving themselves. The final part of the programme is to play on this screen images of branches moving in the wind, and this is to try and destabilise her a bit more, make it much more realistic for how it would be for one of our earliest ancestors to move in the arboreal canopy, where the branches are all moving and which must knock their balance quite strongly.
How are you going to apply this then to orangutans? Because that's specifically what you want to look at.
Of all of the great apes, our closest living relatives, which are chimpanzees, gorillas and orangutans are a really good model because they still live in the forest canopy and because the way they move mechanically, so the forces and movements that they use, is more similar to humans than the way chimpanzees and gorillas walk bipedally. So they're a great model, and our next step is to take the beam and the hand supports to Chester Zoo so that we can start to do some experiments on how the orangutans manage to balance on this when they're walking.
And what do you hope to gain from this research?
We hope to gain two things, really. One is a better understanding of how orangutans move in their habitat and how costly it is, because, of course, logging and deforestation is devastating their habitat. And if we can understand their crucial habitat requirements, we can gain a lot of knowledge about where they can be reintroduced and so forth. Our second primary outcome of this project is to understand about our own evolution, to work out why bipedalism evolved, what the benefits were in our early ancestors, and how well adapted our ancestors were to walking on two legs before they came down to the ground.
Susanna Thorpe at the University of Birmingham, and when the equipment goes to Chester Zoo in the summer, we'll be following how the research progresses. I'm at the back of Paddington Station in West London, next to a fairly busy road, and with me is Bob Lowe from the UK Energy Research Centre. One of his areas of research is how to improve the energy efficiency of cities. Now, Bob, you're a building physicist, so let's look at this building here. It's a 5-storey building. We reckon between us, neither of us are architects, we reckon about 200 years old. It's got a rather nice cream facade, large sash windows surrounded by this ornate masonry, and there's a balcony running the length of the building. Now, this is a nice building. You would not want to tear it down, but I guess it's not energy efficient.
Probably isn't energy efficient. Things will have been done to it over the years. It's almost certainly got some double glazing. In fact, I can see the double glazing there. It will have modern heating, ventilating systems inside, but basically the envelope is solid wall, no insulation, very high heat loss. So if you want to do something about the energy consumption of London as a whole, you actually have to deal with hundreds of thousands of buildings like this in order to crack that problem. And nationwide, there are something like 7 million solid wall buildings.
Just on the junction we're standing at, these buildings stretch all the way down the street into the distance. We are surrounded by them. So here's the question: how do you make this more energy efficient?
Well, we did have a look at the back on our way round, and one of the things about buildings of this age is that very often the back is much, much plainer than the front, and it actually turns out that you have more wall area at the back because the back goes in and out with things that up in Yorkshire we call offshots. I don't know what you call them down here, kitchen extensions and so on, often built in when the buildings were first built. So you've probably got 50% more wall area, and in principle, you can insulate it.
The thing is, I suppose, you wouldn't design a modern city if you were trying to reduce its carbon footprint like this. Well, like the junction here, for example, with blocks of 4 roads going off in each direction, busy road here, and solid walls.
And yet there are some things that the Victorians got very, very right indeed. These days, it's almost impossible to replicate this kind of urban environment under modern planning rules, with rules for roads, turning radiuses for traffic and so on. So this is very, very difficult to replicate.
So what's good about this?
What we have here is very high density. It's then relatively straightforward to connect this to effective public transport systems, buses, the underground system, something that occurs in very, very few other cities in the United Kingdom. I can think of maybe 2 or 3 cities that have significant underground railway systems. So what we have here in transport terms is extremely efficient. And you've got to remember that energy consumption is only about 30% of total energy consumption in the UK, and transport is nearly as important and growing much faster.
So if you're looking to, if I use the phrase, to retrofit a city, to make it greener, then you've got to look at all these things. You've got to look at the cladding, the buildings, the transport system, where the energy comes from, the whole lot.
That's right. At the moment, these buildings are almost certainly heated by gas, supplied with electricity from power stations in the rest of the country. Well, in terms of the gas, in terms of the heating, it would be possible to heat the area here with hot water supplied from nearby power stations through pipes, something that's done in many cities, many towns and cities in places like Denmark and Sweden, parts of Germany and so on. That would require significant interventions across the city. It would require a level of planning which the United Kingdom has not been that good at over the last 20 or 30 years since I became involved in this kind of work. These are real problems that don't go away.
Bob Lowe from the UK Energy Research Centre. Thank you very much for joining us in central London. This is the Planet Earth podcast, and if you're a regular listener, thank you. You'll have heard our audio diaries, though. And so far we've had dispatches from scientists working on insects in Borneo and geese in Ireland. But our latest comes from the British Antarctic Survey Research Station on the Antarctic Peninsula.
So, hello, my name's Claire Lehman. I'm a doctor for the British Antarctic Survey, based at Rothera Base. On the Antarctic Peninsula at 67 degrees south. Today we're so blessed with a beautiful day's weather, and I'm just taking the opportunity to get out of the group of guys to go ice climbing. We're very lucky in having glaciers that come right down to the sea. So, got all my kit, full laden rucksack on my back, wearing my thermal, all-important layers. So heading out for a bit of a day on the cliffs, which should be fun. Absolutely stunning day. Very high cloud, the sun visible. Oh, and just trudging across snow here behind the back of the aircraft hangar. We've got a Weddell seal. It's about 5 metres from where I am at the moment. It's managed to create a huge track for itself from the sea. It's about 10 metres inland. Hello. Weddell seals are one of the more friendly seals that we've got on base. They kind of look a bit cat-like, their eyes quite inquisitive and not in any shape or form dangerous or aggressive, unlike their counterparts, the fur seals, which seem to have overtaken base at the moment. You can gnash their teeth and run after you at quite a speed. The Weddell seal, on the other hand, quite happy. I'm just standing here about 5 metres away from it, soaking up the sunshine. They've got very beautiful silvery fur with sort of paler grey spots upon it. And they're very loud at breathing. I'm going to try and get closer so you can hear how loud a Weddell seal is at breathing. Hello. We have to be very self-reliant here. Not just me as a doctor, but everybody. We've got plumbers, electrician, generator mechanic, vehicle mechanics, communications officers, meteorologists, chef, very important. Each of us in our own field has to be certain that we can deal with whatever challenges may face us in the course of the coming months. Back in the UK, I'm used to having team of other doctors to help me out, and a group of nurses, even secretaries, whereas here there's certainly no other doctors and there are certainly no nurses. So I've had to train up a group of willing volunteers to become medical assistants. They even have to train to be my dental assistants, and even anaesthetics as well, should the need arise. I sincerely hope not. In addition to all those, we actually form our own search and rescue facility as well. Although it's great fun to come up here ice climbing, there's actually a slightly more pressing need for it as well, insofar that should anybody befall an accident, we have to rescue the individual ourselves and treat them. So for me, acquiring mountain skills is really important. For the other guys, acquiring skills on how to deal with casualties out in the field is also really important too. So I'm going to head up now, go and start ice climbing.
Claire Lehman, the doctor at the British Antarctic Survey's research station at Rothera. We'll put up a picture of Claire on our Facebook page and hear more from her in the coming weeks. You can catch up with previous audio diaries on the Planet Earth online website. And with me is Tamara Jones with some other stuff on the site at the moment. And I like this idea, this proposal really, for citizen scientists.
Well, there's been a lot of talk recently about the changes in global biodiversity, and especially in this year, which is the International Year of Biodiversity. But for scientists to get some idea about how biodiversity is changing, they need to be able to have historical data and modern data to compare. They need to have some sort of baseline. But the trouble is, in the last, say, 30 years or so, they've been concentrated on gathering data on threatened species or charismatic species, and there's really been a gap in data on common species. So what these scientists are calling for is a single website where anyone, or sort of natural history enthusiasts, can record sightings of common species such as the birds you'd find in your garden.
So even the birds around us, like the pigeons or whatever?
Yeah, absolutely. Pigeons, sparrows, anything really, because we have no idea whether or not some of these species may actually become threatened in the future.
Now, one of the stories that's shocked me in the last couple of weeks is this story of the plastics found in the sea around Antarctica.
Yeah, it's pretty scary, really. I mean, we know that plastics are travelling around the world's oceans, but in this latest research, the scientists found that these plastics had found their way to the most remote seas in the world around Antarctica. And what's interesting about this is that there are no research stations or bases anywhere near this sea, which suggests that these plastics must have travelled around the world's oceans, for miles. So we really have no idea where these plastics come from, only that they've travelled a long, long way. So
effectively now, you could say that the oceans are polluted everywhere with this stuff.
Pretty much, yes. And what's interesting is that the scientists also sampled the ocean floor, and luckily they found no evidence of plastics on the ocean floor, but they don't think it's going to be long before they find plastics on the ocean floor.
And very briefly, also on the site, there's this video of wind in Greenland and some stuff on coral reefs.
Well, there's a researcher who from the University of East Anglia who went off to the seas off the southeast coast of Greenland to look at how the winds around the area affect the oceans around there. And he's actually recorded some video of his experiences. In that area of the world, you get some of the fastest winds in the world on the planet. So some of the video he's recorded is pretty hair-raising.
Yeah, be warned, don't look at it if you're about to go on a cross-channel ferry. And then there's coral in Indonesia.
Yeah, we have some other researchers who've gone off to Indonesia to look at coral reefs, to look at how environmental change is affecting them. Things like rise in sea levels, how's that going to change coral reefs, and how will ocean acidification affect these coral reefs?
Well, thanks, Tamara. We hope to have some audio diaries and some videos from those guys in Indonesia at some point in the future. And more on all those stories on the Planet Earth online website. You can also follow us on Facebook and Twitter. And I do want to mention that in a couple of weeks I'm off to the Arctic with the Scottish Association for Marine Science. I'll be filing regular updates as we head north into the polar ice. In the meantime, if you've any comments or suggestions, please do get in touch. I'm Richard Hollingham, and this has been the Planet Earth Podcast.